Picture this. You're standing at the starting line of a drag strip in 1971, watching two identical Plymouth Cudas with identical 340 engines line up. Same weight, same tires, same driver skill level. The Christmas tree drops, both cars launch hard, but one consistently finishes 0.2 of a second quicker. Not because of more power, not because of better traction, but because the winning car is shifting fewer times. That's right, fewer shifts, faster times. This is the story of how one California racer discovered a transmission trick so effective, so devastatingly simple, that the NHRA had no choice but to ban it from competition. The year was 1971, and Herb McCandless was not your typical weekend warrior at the drag strip. This was a man who approached racing like a scientist, approaches an experiment, methodically, relentlessly, and with an obsession for finding every possible 0.1 of a second. McCandless ran in NHRA's super stock class, where rules were strict and creativity was currency. You couldn't just bolt on a bigger engine or run racing fuel. You had to work within the rulebook, and that meant finding advantages where nobody else was looking. McCandless had been campaigning his Plymouth for several seasons, running respectable times, but always feeling like something was holding him back. He'd studied his time slips obsessively, comparing segment times, analyzing where he was losing ground to the competition. The pattern was clear. He was losing time during shifts, not because he had a bad transmission, but because he had too good of one. The Chrysler Torqueflite A727 was a 3-speed automatic, and every shift cost precious milliseconds. The 1-to-2 shift, the 2-3 shift, each one represented a momentary interruption in power delivery. Meanwhile, Chevrolet racers with their 2-speed power glides were only shifting once. Here's where it gets interesting. The Torqueflite was actually the superior transmission in almost every way. Chrysler had introduced it in 1956 as a replacement for their troublesome PowerFlight 2-speed. The A727 version that came behind big blocks was a beast. It used a Simpson gear set with a 2.45.1 first gear, 1.45.1 second gear, and direct drive third. The torque converter featured a stall speed around 1/800 RPM in stock form, though racers quickly learned to modify these for higher stall speeds. The transmission case was cast iron until 1962, then aluminum to save weight. Inside, 3 multiple-disc clutch packs handled the gear changes, along with 2 bands for holding specific elements of the gear train. The Torqueflite's strength was legendary. It could handle over 500 pound-feet of torque in stock form, where a power glide would grenade at those levels without serious modification. The valve body was a masterpiece of hydraulic engineering, using governor pressure and throttle pressure to determine shift points. Spring rates in the accumulator determined shift firmness. The intermediate clutch pack used 5 friction discs and 5 steel plates, while the forward clutch used 4 of each. These clutch packs were bathed in Dexron automatic transmission fluid, which Chrysler specified after extensive testing showed it provided the best balance of friction and cooling properties. But here's the thing about drag racing in superstock. Strength didn't always equal speed. McCandless understood that every shift represented a loss of momentum. When the transmission shifted from first to second, there was a momentary drop in engine RPM, a brief interruption in acceleration. Same thing happened on the 2-3 shift. The Powerglide guys only had one interruption. They were giving up the mechanical advantage of that intermediate gear, sure, but in a quarter-mile drag race, momentum mattered more than mechanical advantage. McCandless started thinking, what if he could make his Torqueflite behave like a Powerglide, not by replacing it, but by modifying its shift pattern? The rulebook said you had to run a Chrysler transmission in a Chrysler-powered car, but it didn't specify how many gears that transmission had to use. The solution came to him during a late-night session in his garage. The Torqueflite's intermediate clutch was what engaged second gear. Without it, the transmission couldn't achieve that 1.45:1 ratio. But what if he simply removed it? The transmission would try to shift to second, find nothing there, and default to the next available gear, third. In essence, he'd have a two-speed Torqueflite that shifted directly from the 245.1 first gear to 1.1 third gear. The modification itself was surprisingly straightforward, which was part of its genius. McCandless would drop the transmission pan, remove the valve body, and pull out the intermediate clutch pack entirely. The friction discs, the steel plates, the pressure plate, the return springs, all of it came out. He'd then modify the valve body, blocking the passages that supplied hydraulic pressure to the now absent intermediate clutch. A few drill bits and some epoxy were all it took. The accumulator spring for the 1-2 shift was removed since there was no 1-2 shift anymore. The governor valve was recalibrated to trigger the shift to third at the right RPM. But McCandless wasn't done. He realized that without the intermediate clutch, all the stress of that massive ratio drop from 2.45:1 to 1.1 would fall on the direct clutch pack. In a stock Torqueflite, the direct clutch only had to handle the relatively small ratio change from 1.45:1 to 1.1. Now it was handling a much more violent engagement, so McCandless added extra clutch discs to the direct pack. Where stock used 4 friction discs, he crammed in 6, sometimes 7. This required machining the clutch drum for extra clearance, but the added friction surface area was crucial for survival. The first test came on a quiet Tuesday morning at Orange County International Raceway. McCandless warmed up the 340, staged carefully, and launched. The car left hard in first gear, the 2.45:1 ratio multiplying the engine's torque. At about 5,500 RPM, right where second gear should have engaged, the transmission shifted directly to third. The RPM dropped from 5,500 to about 3,200, a massive 2,300 RPM drop. In a conventional 3-speed shift pattern, the 1-2 shift would drop the engine about 1,500 RPM, then the 2-3 shift would drop it another 800 RPM. McCandless was taking all that RPM drop in one shot. The result was immediately apparent on the time slip. His 60-foot time was identical to his previous runs, but his elapsed time was 0.18 seconds quicker. That might not sound like much, but in superstock racing, where races were decided by hundredths of a second, it was like finding a 20-horsepower increase, and he hadn't touched the engine. Word spread quickly through the Mopar racing community. McCandless wasn't trying to keep it secret. He'd share the modification with anyone who asked. Soon other racers were showing up at tech inspection with suspiciously quick Torqueflite-equipped cars. Dick Landy, another legendary Mopar racer, adopted the modification for his superstock Dodge. Sox and Martin, the most successful Chrysler team of the era, experimented with 2-speed Torqueflites in their test cars. The physics behind why it worked so well were simple but powerful. In a perfect world with infinite traction and no parasitic losses, having more gears would always be faster. You'd keep the engine in its optimal power band constantly. But drag racing doesn't happen in a perfect world. Every shift costs time, typically about 0.15 to 0.20 seconds for a well-tuned automatic transmission of that era. The shift itself takes time, plus there's the recovery period where the engine has to build RPM back up. With the 2-speed setup, McCandless eliminated one complete shift cycle. There was another advantage that became apparent over time. The massive RPM drop on the single shift actually helped with traction. When the transmission shifted from first directly to third, the sudden drop in wheel speed gave the tires a moment to recover grip. It was like a built-in traction control system. Cars that had been spinning the tires at the top of first gear would hook up better with the 2-speed modification. Chrysler engineers were not amused. They'd spent years developing the Torqueflite as a 3-speed transmission, carefully calculating gear ratios, clutch pack capacities, and hydraulic pressures. The intermediate clutch was there for a reason, to provide a smooth, progressive acceleration curve and to reduce stress on drivetrain components. Running without it was never part of the design parameters. Internal Chrysler documentation from 1971 shows that engineers tested McCandless modification in their own facilities. They found that while it did indeed provide quicker acceleration in drag racing conditions, it put extreme stress on several components. The direct clutch pack was seeing engagement speeds and torque loads far beyond its design limits. The input shaft was experiencing torsional stress that could lead to fatigue failure. The torque converter was cavitating under certain conditions due to the violent speed changes. In one test, Chrysler engineers ran a 2-speed modified Torqueflite for 50 consecutive passes on their chassis dyno, simulating drag race conditions. The direct clutch pack failed catastrophically on run 37, welding itself together and locking the transmission in third gear. The temperature of the transmission fluid had reached 340 degrees Fahrenheit, well beyond the 250-degree maximum recommended operating temperature. The forward clutch drum showed stress cracks under microscopic examination, but racers didn't care about 50 consecutive passes. They cared about winning on Saturday night, and if the transmission needed a rebuild every 20 runs, that was just the cost of going fast. McCandless himself went through clutch packs like other racers went through spark plugs. He'd developed a routine, run 5 or 6 passes, drop the pan, check the clutches, replace as needed. A fresh set of Alto Red Eagle friction discs cost about $40. A win at a national event paid $500. The modification evolved as more racers adopted it. Some discovered that using different friction materials could extend clutch life. Ray Bestos developed a special compound specifically for 2-speed Torqueflites that could handle the extreme engagement speeds. Others experimented with different shift points. McCandless originally shifted at 5,500 RPM, but some combinations worked better at 5,800 or even 6,000, depending on the engine's torque curve. Transgo, a company specializing in transmission shift kits, actually produced a commercial kit for the 2-speed conversion. Their kit included a modified valve body separator plate, blocked passages already drilled, and detailed instructions for the modification. They sold it as the TF2 Speed Kit, price $89.95, with the disclaimer "for off-road use only" prominently displayed on the package. They sold over 300 kits in 1972 alone. The NHRA was watching all of this with growing concern. The Superstock class was supposed to showcase factory performance, not transmission trickery. The rulebook stated that all factory-equipped components had to be retained, but it was vague about whether those components had to actually function. McCandless and others argued they were still running a Torqueflite transmission, just not all of it. The controversy came to a head at the 1972 Winter Nationals. McCandless had just won his class, running a 1142 at 117 miles per hour, when a competitor protested his transmission. NHRA tech officials dropped his transmission pan right there in the impound area. When they saw the missing intermediate clutch, they had a decision to make. The rulebook didn't explicitly prohibit removing internal transmission components, but this clearly wasn't what Chrysler had intended. After a 3-hour deliberation that included phone calls to NHRA headquarters in California, the officials made their ruling. McCandless could keep his win, but effective immediately. All automatic transmissions in Superstock competition must utilize all forward gears. No more 2-speed Torqueflites. The advantage was simply too great, and it was turning Superstock into a class about who could best modify their transmission rather than who had the best combination of factory parts. The ban was officially added to the 1973 NHRA rulebook. Section 8.4.3 now read, "All automatic transmissions must utilize all forward gear ratios as designed by the manufacturer. Removal or disabling of any clutch pack, band, or gear set is prohibited. The penalty for violation was immediate disqualification and possible suspension from NHRA competition. But the cat was out of the bag. Bracket racers, who ran under different rules, immediately adopted the two-speed modification. Street racers, who ran under no rules at all, made it standard practice. The modification lived on in other forms of drag racing where it wasn't explicitly banned. Even today you'll find two-speed Torqueflites in nostalgia, super stock cars, index racing, and certain bracket racing classes. The technical legacy of McCandless's innovation extended beyond just Mopars. Ford racers started experimenting with two-speed C6 transmissions, removing the intermediate clutch in the same way. GM racers, ironically, started adding gear sets to their power glides to make them 3 speeds, having realized that maybe having that extra gear wasn't such a bad thing after all if you could make it shift quickly enough. Transmission builders learned valuable lessons from the two-speed experiments. They developed better friction materials that could handle extreme engagement speeds. They designed stronger clutch drums that could accommodate more friction discs. They created more sophisticated valve bodies that could produce quicker, firmer shifts without the harshness that damaged components. Many of these innovations found their way into modern racing transmissions. Art Carr, who would later become one of the most respected transmission builders in drag racing, credits McCandless's two-speed modification as a turning point in transmission development. Herb showed us that we were thinking about transmissions all wrong, Carr said in a 1985 interview. We were trying to make them shift smoother, when we should have been trying to make them shift less. That revelation changed everything about how we approached transmission modification. The modification also exposed a fundamental truth about drag racing. Sometimes the best engineering solution isn't the most elegant one. Chrysler's engineers had created a sophisticated 3-speed transmission with carefully calculated ratios and smooth shifts. McCandless turned it into a brutal 2-speed that violated every design parameter, but it was faster where it counted, on the drag strip. Modern 8, 9, and 10-speed automatic transmissions might seem to contradict the fewer shifts are better principle, but they actually validate it in a different way. These transmissions shift so quickly, often in less than 100 milliseconds, that the time penalty is minimal. They keep the engine in such a narrow RPM range that it never falls out of its power band. They achieve through technology what McCandless achieved through elimination. The specific technical details of the two-speed modification became even more sophisticated over time. Racers discovered that the size of the orifice feeding the direct clutch could be enlarged to speed up engagement. A 0.093-inch drill bit was the standard, but some went as large as 0.125 inch. The check ball in the valve body that controlled the release of the forward clutch could be replaced with a lighter one, allowing quicker pressure release. The accumulator spring for the remaining shift could be shimmed to increase pressure, creating a more positive engagement. Temperature management became crucial with the two-speed setup. The extreme clutch engagement generated enormous heat. McCandless eventually added a transmission cooler with twice the capacity of the stock unit. He ran a high-flow pump kit from TCI that increased fluid circulation by 30%. He even experimented with different fluid types, finding that Type F fluid, designed for Ford transmissions, actually provided better friction characteristics for the brutal engagement than Chrysler's recommended Dexron. The actual shift point optimization became a science unto itself. McCandless kept detailed notes on every pass, correlating shift RPM with elapsed time. He found that shifting too early, below 5,400 RPM with his combination, would bog the engine in third gear. Shifting too late, above 5,700 RPM, would over-rev the engine and move past peak power. The sweet spot was 5,550 RPM, plus or minus 50 RPM, depending on air density and track temperature. He'd adjust the governor weights to achieve this precise shift point. Durability improvements came through experimentation. McCandless discovered that using Colleen steel plates instead of stock steel plates in the direct clutch pack reduced heat buildup. The Colleen plates were chemically treated for better heat dissipation. He also found that mixing friction disc materials, using 3 Alto Red Eagle discs and 3 Ray Bestos Blue Plate Special discs, provided the best combination of initial bite and sustained friction. This hybrid clutch pack could survive 20 passes instead of the 5 or 6 he was getting with stock materials. The financial impact of the modification was significant. A properly built 2-speed Torqueflite cost about $600 to modify in $1972, including the valve bodywork, extra clutches, and cooler system. But it provided the equivalent of a $3,000 engine rebuild in terms of elapsed time improvement. For budget-conscious racers, it was the best bang for the buck in superstock racing. When the NHRA ban came down, some racers tried to circumvent it. They'd install the intermediate clutch pack, but use very weak return springs so it would slip continuously, essentially making it non-functional. Others would drill the friction discs full of holes, reducing their surface area to almost nothing. NHRA tech inspectors quickly caught on to these tricks and started checking not just for the presence of all clutch packs, but for their proper function. McCandless himself moved on to other innovations after the ban. He developed a technique for modifying the Torqueflite's valve body to produce quicker shifts without removing any components. His controlled leak method involved drilling precise orifices in the separator plate to bleed off just enough pressure to speed up shifts without causing slippage. This modification was legal and became standard practice in superstock racing. The 2-speed Torqueflite story represents a perfect moment in drag racing history when innovation, regulation, and competition collided. It showed that sometimes the best solution isn't the most sophisticated one. It proved that racers will always find creative interpretations of the rulebook, and it demonstrated that even the best engineers can't anticipate every possible use case for their designs. In the end, Herb McCandless's 2-speed Torqueflite was more than just a transmission modification. It was a philosophy, a statement that in drag racing, less could indeed be more. Every shift costs time, every component adds weight, every system introduces potential failure points. By simplifying the Torqueflite down to its essential elements, McCandless didn't just make it faster, he made it perfectly suited for its singular purpose, getting down the quarter mile as quickly as possible. The legacy lives on in unexpected ways. Modern dual-clutch transmissions essentially operate on a similar principle. They pre-select the next gear to minimize shift time. CVT transmissions eliminate shifting altogether. Electric vehicles with single-speed transmissions have proven that with enough torque, you don't need multiple ratios at all. McCandless was ahead of his time in understanding that the best transmission might be the one that transmits power most directly, not most sophisticatedly. Today, surviving examples of 2-speed modified Torqueflites are valuable pieces of drag racing history. Collectors pay premium prices for valve bodies with the telltale blocked passages, for clutch drums machined to accept extra discs, for the Transgo TF2 speed kits still in their original packaging. They're reminders of a time when one clever racer could outsmart a team of engineers, when innovation happened in garage workshops instead of computer simulations, and when going faster meant thinking differently, not just spending more money. The California superstock scene of the early 1970s was never quite the same after the 2-speed ban. Racing got more expensive, more sophisticated, more regulated. But for a brief, glorious period, Herb McCandless and his fellow innovators showed that sometimes the best modification is a subtraction, not an addition. They proved that understanding the principles behind the engineering mattered more than accepting the engineering as gospel. And they demonstrated that in drag racing, as in life, The shortest distance between 2 points isn't always a straight line. Sometimes it's skipping a gear entirely. What made McCandless's innovation truly remarkable wasn't just its effectiveness, but its elegant simplicity. In an era when racers were adding components, bigger carburetors, wilder cams, additional fuel systems, McCandless was removing them. He understood something fundamental that others missed. In a race measured in seconds, every fraction counts, and sometimes the best way to save time is to eliminate steps entirely. His two-speed Torqueflite didn't just change how racers thought about transmissions, it changed how they thought about problem-solving itself. The NHRA's ban on the two-speed modification stands as one of the most significant technical rulings in superstock history. It acknowledged that McCandless had found something so effective, so game-changing, that it threatened the competitive balance of the entire class. That's the ultimate compliment for any innovation, being too good to be legal. McCandless didn't just outsmart Chrysler. He outsmarted the entire drag racing establishment, forcing them to rewrite the rules because he'd found an advantage nobody had anticipated. Think about that the next time you're watching modern drag racing with its computer-controlled everything and corporate engineering teams. Remember that once upon a time, a guy in a California garage figured out how to go faster by making his transmission worse, not better. He turned a sophisticated 3-speed into a brutal 2-speed and proved that in racing, as in many things, perfection isn't about having more, it's about needing less. If you've ever wondered why certain modifications become legendary in racing circles, the 2-speed Torqueflite is your answer. It wasn't just fast, it was ingenious. It wasn't just effective, it was revolutionary. And even though it's been banned for over 50 years, racers still talk about it with a mixture of admiration and awe. That's the mark of true innovation, when something becomes more famous for being banned than it ever was for being legal. What's your take on this legendary modification? Have you ever seen or heard a 2-speed Torqueflite in action? Drop a comment below and share your thoughts on this piece of drag racing history. And if you enjoyed this deep dive into one of racing's most ingenious banned modifications, make sure to subscribe for more stories of automotive innovation, engineering, rebellion, and the relentless pursuit of speed.